So this is question 17, Higher Paper 1 2012. We have a dot product of two vectors. One of the vectors is A, the other vector is A plus B. Now the dot product, interesting operation between two vectors. Take the dot product, length of one of them times the length of the other one times the cosine of theta. Or if you happen to know the components of the two vectors, then you can prove that the number you get from doing this, length times the cosine of the angle between them, you can prove that that number is exactly the same as the number you get by multiplying these components together and adding the results. Z1, Z2. Now basically that's not going to help you solve this question, but one of the things that arises from this definition is just a wee review of the thing, but one of the things that does arise from this definition is that if you have a dot product between two vectors and one of the two vectors is a sum of another two vectors like this, then you can get rid of brackets as though it was normal algebra that you were performing. Now it's not normal algebra. These things do not stand for numbers. These are vectors. But the dot product is a number. If you take two vectors and find the dot product, or scalar product as it's called, you will get a number. That's a number. So this dot product is a number. This dot product's a number. This dot product is a number. But this is a property of the dot product that you can prove from the definition of a dot product. Now, this dot product, we are told, is 7. We know that we can get rid of brackets here, and therefore we can take the dot product of A with each part of this sum. So A dot A plus A dot B, and that equals 7. So what can we do with this? Well, A dot A is interesting because I know what A is, and I do have this definition that says if I know the three components of the two vectors, then I just multiply the corresponding components and add. That will give me the dot product. So for this part, 3, 4, 0 dot 3, 4, 0, I can do a calculation. I don't know about A dot B. In fact, that's what the question's asking me to find. So I think we're making progress. This is 3 times 3 plus 4 times 4 plus 0 times 0. That's 9 plus 16 plus 0. 9 and 16 is 25. So that dot product comes to 25, and that's using this result here. So 25 for this plus the unknown number is equal to 7. So therefore this unknown number, A dot B, is equal to 7 minus 25. Take away 25 from both sides of this equation. So A dot B finally is equal to minus 18. So let's have a look at the possible answers. And there it is, negative 18, choice D.